your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. If you are a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com. First Updates Now is supported by Kettering University. Over one-third of Kettering's current students are former robotics team members. Go pro at Kettering University and get a free t-shirt. Students in grades 8 through 12 and located in the continental U.S. scan the QR code and complete the form by January 31st, 2022 and receive more information about Kettering.
Hi, my name's Ben. I'm with the Kettering Bulldogs RI3D team, and this is our first day recap of the 2022 FRC game Rapid React. I'm going to hand it off to Luke.
Hi there, like Ben said, my name is Luke, and I'm going to be talking about the strategic priorities that we decided on for this weekend. So first off, we started with our quote-unquote zero priority, which is driving. We said this was zero because it's something that enables us to do the rest of the game challenges, so we put it right at the top like that, but it wasn't a real priority. That's just mobility right there. So we started there, and then we went into our first priority of intaking cargo from the floor. We ultimately decided that it might be easy to take in cargo from the terminal, but we decided that since there were probably going to be a lot of cargo all around the floor in high levels of gameplay, it would be beneficial for us to plan on intaking this cargo from the floor so that you're able to collect and be a little bit more versatile. And then if our design allowed it later on, we would be able to, change it a little bit so that we could do both the terminal collection and then intaking from the ground as well. But we'll see. For our second priority, we did shooting cargo into the upper hub. So we decided that overall we were probably going to end up shooting the cargo just based on how we'd be intaking from the floor and then sending it into its scoring location. So we decided to aim high, literally, with going into the upper hub. And then ultimately, if we didn't get there, we would be able to fall back onto shooting into the lower hub if we had problems with motors or power, you name it. So we decided to aim for the upper hub to start with, and then we could always fall back on the lower hub, but we decided to aim for a little bit more of a challenge there. Lastly, we decided to make our third priority climbing to the mid-rung. So we decided that we would want to go for the mid-rung because it was a little bit more than the low rung, and you do have to extend out of your starting configuration for that. So it was a little bit of a challenge, but we felt that the point increase and the versatility overall when you are playing this game with other teams and you're looking for those ranking points, it might make it a little bit more easy to get that overall if you're able to contribute that extra rung worth of height and points. So we decided that we would want to go to the mid-rung and go forward with that challenge a little bit more. So overall, those are our strategic priorities, and Nick is going to talk about the design that these led.
Hey everyone. So, I'm Nick Lipchick, and you probably haven't seen a whole lot of me today because I've kind of been tucked in the corner grinding out CAD for the robot. So while everyone else has been prototyping with the game pieces and testing things like what compression works best and what wheel type we want to use, I've been working on a lot of the top-level robot architecture, just making sure that we can fit things where we want to fit and getting a general layout of the new robot. So I think Tyler is going to pull up CAD eventually, but I've got this nice Crayola CAD drawing here before he does. And you can see that, of course, for intake, we want it to be full width. We want to be able to pick up balls driving into them, no matter the orientation. And then I think the most unique thing about our robot right now might be that our shooter is actually offset to one side. So of course you've got the indexer, and it'll kick both balls to the side before bringing them up. The reason for this is that we knew that if we took two balls in side by side, that we would have trouble singulating them to the center of the tower. So by offsetting the shooter, we could make sure one ball got sucked in first before the other would follow it. And then finally, that also gives us the space to put the climber in the box in the corner and just left us with the best overall packaging. So still don't see CAD, so I'm not sure if you're actually going to get that, but if you
We're going to put up CAD in just a second, but just a reminder, if you haven't seen in chat, type cargo in chat right now, and that's your chance to win a $25 gift card from AndyMark. So let's take a look at what you guys got for CAD.
Yeah, so if you want to check out the CAD for yourself, it's far from done, and I'm sure some sacrifices will be made because this is a robot in 3 days. But our CAD is in a public Onshape document that was linked on the Chief Delphi forum. So feel free to go into that, play around, move whatever you'd like to, and that will continually update over the next couple hours. So you can follow our design progress live and stay tuned there. And with that, I'm pretty sure that's all for the overall design. I will kick it off to the chassis. Forgive me, I'm going to be staring at the iPad to see what you guys can see. I think the biggest thing is that you can see our huge master sketch, which all of the other subsystems are derived off of. And we love formatting our design like this because it lets us easily change parameters of the design, like ball compression and where subsystems are, without going into multiple different documents and manually changing the dimensions. So I always love looking at sketches like that. I think it's super cool. And hopefully you guys will too. Like I said, the Onshape link is in the Chief Delphi. Feel free to poke around. With that though, I will be kicking it off to the chassis.
So hello everybody, my name is Kirsten Smith and I am here to talk to you about the chassis that we have been building today. Right now this is the kit of parts chassis that comes in everybody's kit of parts. We have the standard 6-wheel drive tank system with the normal wheels that come with the chassis. But we did something different. Instead of using a sim motor like we have in years past, this year we have used Neo motors from Robotics. We decided on Neos because they are slightly more efficient and like the performance is slightly better. But right now we haven't made any other major modifications to the chassis. It is the standard kit of parts. We will have a belly pan in it for our electronic systems pretty soon, and we decided to put the belly pan at the back half of the robot because we'll have the space there. Other than that, it's your standard chassis, and there's pretty much nothing else to talk about. So I will be handing it off to the shooter.
All right, before we get there, we're going to draw for the AndyMark giveaway, and the winner of that is going to be Indy Sam. Congratulations for taking that. By the way, if you do win, please make sure you shoot First Updates Now a message on Twitch or Discord with your email address and your name. And if it's a physical gift, which we'll have in a little bit, make sure you also let us, lots of rigged emotes in chat, by the way. Make sure you also let us know your mailing address. We're going to keep going with giveaways, by the way, and start another one from our friends at Robotics, who's also supplying a $25 gift card. So if you're interested in winning one from Robotics, just type Rev in chat, and we'll be drawing for that in a little bit.
All right, sweet. So I'm here to talk about our shooter for the balls this year. And what we got here is pretty simple and untested at the moment. So it's, might be changing a lot. So we're going to be testing that soon after here. But pretty simple shooter. Will probably be more oriented like that. It is currently using 2 Falcons, 1 on each side, and we have some 4-inch Coulson wheels. We will definitely be trying some different wheels and different compression. That's one advantage of this Lexan that we have here, that you can pretty easily change compression with it. So again, dual Falcons. Falcons are a little bit of a pain to get right now, a little bit of a challenge. So you could easily use Neos or sim motors, or probably some 775s with a gearbox would work great. So we luckily have some Falcons, and that's what we're going to use, but there's plenty of other options that would probably work. So yeah, now I'm going to kick it over to talk about the intake and how we're going to get balls up to this.
All right, well, I worked on the intake all day, so it's pretty basic right now. It is just metal bar that we slapped a roller on with some compliant wheels throughout the day. We've been testing this on the stream, and we've tested multiple different kinds of wheels so far. We started with the Mechanism plastic wheels. We tried those. They didn't necessarily work as well as we thought they would, sadly. And then we moved on to the black compliant wheels that have a lot of squish, but they ended up intaking the cargo very well. And we also tried these gray compliant wheels that they were so-so, so we ended up deciding to go with the black compliant wheels. And so far, that's what we've been doing with the intake. So I'm going to go ahead and move on to the next thing.
Hello. I hope this is working. My name's Giovanni. I worked mainly on the climb today. So we will be using Andy Mark's two-stage climber in a box for this year's robot. Yes. Oh, yes. Yeah, if you want to show me the hook and stuff. It's not fully constructed yet, unfortunately, but how it works is it's a spring and winch style mechanism. So basically, when you want to, the winch lets go and the robot rockets upward via some inward springs. And then once it's upward, the robot can tighten it back down via the winch using a motor. And it's a very quick method in order to get the climb and successfully lift off the ground. Usually these things, like end game activities, are very hard to do, and something like this is a very simple design that makes the turbulation of it much easier. So yeah, I believe that covers the main parts of the climb. We will be Are we moving on to? Yes, we'll be moving on to the next mechanism now. I believe it's electrical.
And before we do that, we're going to draw for the Rev gift card. So let's go ahead and do that. And the winner of that is going to be Peyton's winning that. Wow, Peyton, you're on a roll right now. He's won a couple of giveaways recently. Congratulations, Peyton. And guess what? The next thing we're giving away, I think we could use a nice model on camera, is actually a Kettering RI3D t-shirt that's being modeled right now. So give us a nice spin, show us what they can potentially win for that. And if you're interested in winning that, you do have to live in the continental U.S., by the way, for shipping on this. And the keyword is going to be GoPro, 2 words, because you can go pro at Kettering University. GoPro, 2 words, for a chance to win a t-shirt, and you must live within the continental U.S. Good luck to everybody.
All right. Hello, everyone. My name is Ian Steffes. I've been working on electrical all day. So what we did basically is we made a map of what our current plans are of where the items are going to go. So this is just a rough draft, though, and this is not final. Our next part is these are the actual items that we are currently planning on using, which is 4 Revos with sparks, 4 Neos with sparks, and that for the drive, and then the climb would be 1 Neo and 1 Spark, and then the shooters is a double Falcon, which can be seen right here, and then the intake and uptake and index are all going to be 775s with Talons, and then let me actually show you what these items look like. So this is a Spark. This is the part that's the controller. We spent most of our day setting them up so that they could be plugged in. And then this is a Neo. It's a brushless motor. It's what we're using. And then the last one is the Falcon, which you guys have already seen. And then the rest of the items are currently in programming, which will be our next person.
Hey everyone, I'm Jesse. I'm the programming lead here, and I'm here to talk about what I've done. So there hasn't been all too much actual programming being done. It's mostly just software installation, firmware updating of the various electrical components that you just saw, including the new power distribution hub from Robotics and the new pneumatic distribution hub of the same variety. But drive code is done as far as actual programming goes. It just needs to be tested. And from there, I plan on moving into intake code and then shooter code, and we're going to go from there. So that's as far as programming has gotten. Not all that much, but, it is what it is. So now I'm going to pass it back off to Tyler to wrap it up.
All right, Chad, so if you have any questions, we'll entertain that for just a couple of minutes on there. We do have, let's draw for the giveaway once again. I think we need a team member back on screen to show off the t-shirt. That's going to be given away on there, so let's go and do that. Thanks, Luke. So the winner of that is going to be Donuts 54. Nice name, by the way. Congratulations for winning the t-shirt on there. Yeah, if you have questions, by the way, at First Updates Now, please type them in the chat. This is your time to do it, where we can pull in members from the team to do that. We do have one more giveaway to do, and then we'll take any questions that come in. By the way, so we have one more giveaway from our friends at the Thrifty Bot, who are actually giving away some of the squish wheels. Can we grab that intake again and show that off? So we have 10 2-inch Thrifty squish wheels from the Thrifty Bot. And if you're interested in winning those, like I said, these are what are being used currently right now on the RI3D, the Bulldogs intake. And the keyword is going to be go ham. You're going to have to ask Ryan the meaning behind that, but go ham, 2 words, is the keyword for that. Type that in chat, and we'll go through. So real quick, what we asked as we go through, we've filmed some videos today that will be coming out on Fun's YouTube page on it, but one of them definitely was a big one, is showing off the different wheels from that. Can we go, I know we talked about it a little bit, but can we go more in and maybe show a demo of the wheels actually working with the drill and how that worked for the intake?
Do you want me to operate and you talk? Let's switch. I got it. Good.
He did it. So, like Tyler said, these are the 2-inch Thrifty squish wheels. So we found a lot of success with these. Our favorite thing about them is they are, like it says in the name, pretty squishy. So when you have these on a shaft, you get the compression of the wheels themselves, and you're also getting the compression of the cargo. That made it so that it was just really conducive to actually pulling in the cargo and getting some positive control of it. So overall, these were our favorite because of that compliance within the wheels. We found that when we were using the other compliant wheels, the gray ones from Rev and the Mechanum wheels that are also from Thrifty, we found that they kind of didn't have as much give. The squish wheels are just so squishy and that they just grab onto the cargo and really pull it in. The Mechanum wheels, we found that you need they were great for actually vectoring the wheels and getting that positive control, but we found that you had to be at a really specific height, so there wasn't a lot of play within the system. You had to be right at the right level, and if the Mechanum wheels were not at the right level, there wasn't much squish to the wheels, so the cargo itself kind of just got kicked away. It was a similar situation with the Rev compliant wheels. Overall, they did work great, but we found that it just wasn't the same as the squish wheels. These are our favorite so far, so that's what we've been using and what we think we're going to continue be using. So as you can see, pretty consistent, and overall they really just give that squish to them.
All right, we do have some questions coming in, so I think we'll take those. Thanks a lot, guys, for showing that off. And anybody can take this who thinks will answer it best. From ArcBL says, what do you think is going to be the most challenging aspect of this robot?
I'll field that one. So maybe this is a personal belief, but we've talked a lot about this. I think shooting in the high goal is going to be deceptively hard. The diameter of the upper goal, and it's about 8 feet in the air, is only about 4 times the width, closer to 5, I guess, of the actual game piece. So from that high, you're going to have a really consistent shooter to keep nailing them in the high goal. So I think teams are going to need to spend a lot of time perfecting their shooters and tuning their code to make sure they're able to reliably hit that. But that's just my 2 cents. Anyone else got a...
All right, we'll keep going with questions that we have. Asking about the shooter, what compression are you looking at for using from the shooter coming from Mac Fraser 3136?
So compression on the shooter, we don't know yet. This is a simple answer. We haven't tested it yet. We're going to test this out with various different compression and also with some different wheels. So again, we are currently running some 4-inch Coulson wheels, but we have a bunch of different types of wheels that we're going to be testing out, and we'll be sure to make a video on that and show that off. So look out for that. But at the moment, we don't quite know what compression we'll be running.
All right, we got a few more questions we'll take from the audience. Just a couple announcements. Once again, type Go Ham for a chance to win those squishy wheels from the Thrifty Bot. If you are planning to stick around and watching live, we will have Kahoot Trivia for Rapid React with more giveaways starting at 9:30 p.m. Eastern. Let's keep going with more questions from MJ2758. For the end game, what is your plan to get from bar to bar? Since you're looking at going from 2 bars, how are you going to get from the first bar to the second bar?
Someone want to talk about that?
So I can take this one. So our plan is to grow to the middle bar, which is the second from the bottom. Right now, we're not planning on going from bar to bar because we can grab the second bar from the ground. The robot, so the robot height, and we can. There is a solid robot height, and we can extend beyond that. So that limit is within the height of the bar. So when we do go to the second bar, we can grab it and pull ourselves up without going beyond the limit. So we do not need to swing from bar to bar.
All right, next question coming in from Richterman says, since the cargo, their words by the way, since cargo are essentially tennis balls, did you ever consider using Velcro in the intake or other parts of the robot?
Whoever tested. Okay.
All right. So we actually, yeah, you could test it. So we actually did test the Velcro, but we realized that there was a key issue with it. It worked a little too good, which ended up resulting in parts of the tennis ball being pulled apart, which could possibly get you trouble during competitions for destroying game pieces.
It's gone.
Next one coming in, Art Bell with another one. Actually, this question is about mechanic wheels with the intake, so I'm just going to read it. I'm not sure if there's anything we might have missed, but it says, do you think that mechanic wheels would work better if the intake was sprung and could rotate? That's a good question, actually.
Yeah, that very well could be. We found that ultimately in our 3 days, it probably wasn't worth all the trouble of dealing with the springs and tensioning everything and making sure that it was exactly how we wanted it to be. But ultimately, that could very well work, a little bit of springiness to make sure that you're compressing down on it. Also, I want to clarify, they do handle the balls pretty well in my opinion. I feel like when you have control of them and they're at that right height, if they're where you want them to be, then and you design it right, then you can definitely have a very positive impact with some vectored intake wheels. I think it's still plausible that we may be able to put these inside a robot to better index them. They might have different applications. It definitely does work with the cargo, but you do need to be in that sweet spot, and having a spring is, I guess, to help find that sweet spot may very well be the solution.
Okay, going a few more questions we have on there. Somebody might have to interpret what this means in particular, but Redstoner331 says, has there been any issues with the fuzz degrading and affecting the performance? Can somebody explain what they mean by the fuzz?
So we actually didn't test it enough to see if there was an actual permanent issue, but we didn't want to destroy the game pieces as it is the first day. We knew that it would possibly destroy them if we continued to practice with this method, though.
Thank you, yeah. Rick Nermont, another one for the dry base. Have you guys considered using swerve at all for the dry base?
Yes, but no.
Yeah, and I think the paraphrase, the dry base, the do swerve would take, I think, way too long for what Robot in 3 days is looking for, right?
I think it would be really cool. That would, if we could pull that off and do all of the other tasks alongside it, then maybe, but I don't think that's really in our scope. And ultimately, I think our goal is kind of more helping other teams to understand what's going on in the game and kind of how we're approaching it if you don't have the same time and resources that some of the, I guess, more fortunate teams would. But a swerve would be pretty cool.
All right, a couple last questions, and if you have any more past that, by the way, you can definitely ask after the show's over, as we'll be going for a long time here. Chicken Skunk says, what is likely going to fail? Is there anything new you've been having issues with, or things that you might have had issues before that you've had some failures with?
That's a really good question. Ultimately, I guess we haven't dealt with the climber in a box yet, so we're still kind of working through that. But I mean, once you get the hang of things, I mean, there's a learning curve to everything. Besides that, each new game element introduces their own challenges. So dealing with the kind of oversized tennis ball is definitely really interesting, and it has been something that we've had to use our brains for. But I mean, you sit down, you think, and you really work with a problem enough, then you can solve it, right? So I guess dealing with all the new challenges that FIRST continually throws at us has been one of the bigger challenges this year, but still working through it, right? And through brainstorming and positive thinking, you can get through it.
A couple last questions coming in. Graga 1642 asking about, in regards to climbing again, what made you want to go for the middle bar, and did you give any consideration for the high bar or the traversal bar?
So we primarily chose the middle rung because the low rung is probably about the same amount of work in our eyes. I think if we were to approach that problem, we'd probably end up using something somewhat active and able to help us climb to the low rung. And if we're already using something active and we can still stay within the ability of climbing just to one rung, if you're choosing between the low one or going a little bit higher and going to the mid rung, and you get more points and ultimately can get closer to a ranking point, this kind of in our eyes helped us to, that justified going to the middle rung, even if it was a little bit higher. But with the climber in a box, which we had, it felt like it was going to be pretty feasible overall. Whereas going to the high rung, beyond that, may be a little bit more difficult. We had in our brainstorming sessions, we had some different ideas, and maybe, if we have some extra time at the end of the 3 days, maybe we could implement something that might take us to the high rung. We're still kind of working everything out, and we'll see where the challenge takes us. But ultimately, for the scope of the 3 days, we just decided that the mid rung would be something that was competitive and be able to get us points. We thought that it was the benefit outweighed the cons and the extra challenges of it, so we chose the mid rung.
All right, we'll try to take these last two questions, and if you have any more afterwards, we'll grab that once the show wraps up. Of course, we'll be streaming. What's the plan right now? How long are we streaming till? Till we fall asleep or what?
I guess till we fall asleep.
All right, cool.
So be it.
So a couple last things from Deli DX. Says, might be a bit early in testing. Have you guys noticed any deflation issues with the game elements or any interactions you might have noticed?
Issues with
yes.
game elements? I do. I guess you can do it after. I did notice something that's pretty important. The low bar is below the max height your robot can reach. Like normally, like the max height. What isn't that right? Because the low bar. Do you want to come up yourself? Oh yeah. So max height your robot can reach is 4 foot 4 inches, right?
All right, so answering the question with the deflation question.
Oh, sorry.
So currently what we noticed is if the ball isn't fully pumped up, it ends up giving a different bounce, which could also give a different result if you shoot it or if you're trying to play the piece. We realized that the better it's inflated, the better it's used.
All right, last question we have here from Z America Z. How do you plan on lining up the high shot, and do you feel you could shoot high as consistently as low?
So in terms of a finite plan for lining up the high shot, we don't have one yet. And in terms of do you think we could shoot high as consistently as low? No, not a chance, not remotely possible. But what we were thinking when we decided to go for the high shot was It is a much higher point value, so we can try for the high shot, and it will be much easier to pivot from the high shot to the low shot if it turns out we're not able to do the high shot, rather than going for the low shot right out of the gate and then realizing that, hey, maybe the high shot was possible. It would be much harder to change your robot to do that. So I guess we'll find out if the high shot is as easy as we hope it is tomorrow or tonight, depending on.
All right, we're going to let,
how much progress we make.
once again, the Bulldogs from Kettering University get back to work in a second. Let's go ahead and draw for the giveaway from the Thrifty Bot. Congratulations, Nick Mathis, 4130. Wow, lots of rigged emotes in chat, please, especially for him. So congrats on that. Make sure you shoot First Updates Now a message for the win on that. Thanks again to the Thrifty Bot. Thanks to Andy, Mark, Rev, and Kettering for all their awesome giveaways. We are going to have the Kahoot coming up in just a little bit, so please stick around. We're going to let the team get back. You'll watch the team for about another 15-20 minutes. Then we're going to do a Rapid React Trivia Kahoot where we're giving away another Rev gift card, another Kettering RI3D t-shirt to some of the winners, so go ahead and do that. So we can't wait to let this team get back to it. Thanks a lot, everybody, and we're going to let the team get back to work. Take care. Thanks to Kettering University for their support of this video. Over 1/3 of Kettering's current students are former robotics team members. Go pro at Kettering University and get a free t-shirt. Students in grades 8 through 12 and located in the continental US scan the QR code and complete the form by January 31st, 2022 and receive more information about Kettering. Thanks to Stryker Careers for their support in this video. First alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in first are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Thank you to Andy, Mark, Rev Robotics, and the Thrifty Bot for being official suppliers of the Bulldogs Robot in 3 days. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.